We are looking to the future as to where we can make things readily available that our students need, that our faculty are going to use. We want to inspire the creativity. We want to inspire research. This is a great place to start, a great place to play and enjoy and learn. We just put in new 3D printers. We're very proud of them and very proud of the use they're getting here in Creative Studios. We have a Mac room, and we have 3 high-powered Mac machines, and our second studio has 3 really souped-up PC Windows machines. Within reason, we have all the different software virtually the same on each one, so that the students will have a choice whether they like Mac or they like PC. Our third creative studio is a presentation studio. It includes enough chairs for a very small audience, a podium, a green screen, as well as a projector. This room can be used for Skype interviews. It can be reconfigured any way the student would like to do it, whether they're doing an interview, a group talk, or some kind of special meeting and Skyping with someone at a different area. We are thrilled to have this addition to the OSU library, and we hope your ideas can come to life here in the Edmon Low Creative Studios.
Hello everyone. My name is Amelia Clark, and I'm here to welcome you to Tech Tuesday at 2 at the Edmon Low Creative Studios. Both the event and this space are designed to encourage students to experiment with some of the latest software and devices. Our mission with the Creative Studios is to take these tools accessible to all OSU students and provide opportunities for students to develop proficiency and a comfort level with the kinds of technology they will need to be successful at OSU and beyond. Tech Tuesday at 2 meets here in the Edmon Low Creative Studios on the first Tuesday of every school month for interactive showcases of emerging and innovative technologies. Last month we learned about Skype, and today we're learning about 3D printing. Library Technology Specialist Shannon Garde will present a brief history of 3D printing, the different types of 3D printers out there, and then talk about how you can get started on your own 3D project right here in the library. If you're watching on today's live stream, you can submit your questions via Twitter using the hashtag LibTech2s, like Tuesday but abbreviated. Along the way, we'll be drawing for prizes, including today's grand prize, a 3D printing pen, as you can see over here. If you're an OSU student, be sure to fill out a prize entry form, and now I'll turn it over to Shannon.
Okay, so welcome everyone to the Edmon Low Creative Studios. Thank you all for coming. I am Shannon Garde, and welcome to my office. Welcome to my playroom. So today, as you've been informed, we're learning about 3D printing. So let's jump right in. Let's get the obvious stuff out of the way. What is 3D printing? 3D printing I define as an additive form of manufacturing objects, layer by layer, using base materials. It can be plastic, it can be metal, it can be glass, it can be, bless you, it can be anything that can be melted or extruded or solidified into an object. So, 3D printing differs from standard manufacturing that you might be aware of. Usual manufacturing processes for making objects, as you see this lovely table before me covered with things that I'd encourage you to come up and play with once we're done. It differs from standard manufacturing in that normal machines, normal parts are cast or mold or put on a lathe, things like that. It's always a subtractive manufacturing process. So 3D printing is an additive. Additive, subtractive, big difference. And that's what makes it unique. And that's also what makes it good for rapid prototyping. So, brief, I promise, history of 3D printing. Can I get some guesses from someone, anyone? Just feel free to shout it out or raise your hand. I'm not particular. When do you think 3D printing was first a thing? Sir? 2000s. 2000s?
Back.
Nope.
Probably 80s.
Excuse me?
Probably 80s.
Around the 80s? Very good. Anyone else? Guesses?
1983, October 2nd.
This guy, get off your phone. All right, smarty. He is correct. 3D printing, as it is known today, was officially, I guess, incepted in the year 1983. This gentleman, Chuck Hull, is responsible for creating the first official 3D printer. Now you have to think back in those days, before most of you were probably born, there was no such thing as rapid prototyping. If you had an idea, if you had a model, if you had a drawing, you even had a digital model, there was no real way that you yourself could turn it into a model without going through a third-party manufacturing company. It cost thousands of dollars. It also cost lots and lots of time. Going from a model to a true object was something that was very difficult in those days. So, our friend Chuck Hull developed the first type of 3D printer. In this case, he used a type of process called stereolithography, which I'll talk about a little bit more later. It's a little bit different from what we know as 3D printing today, though it is still used. 3 years later, he founded the company 3D Systems, which is still in operation today. And again, they still work with stereolithography. And best of all, and what I'm really happy about, is we've always had computer-aided design. Well, we haven't always had it, but we have computer-aided design in many, many iterations. We have hundreds of different types of software modeling programs, and they're all different. So how do you have all of these software programs and this one printer, or this type of device, to get them all put together so that they can be printed? And Chuck thought of that too. By coming up with the file format that is still used today. It's the universal file format for 3D objects. You've all heard of PDFs. Stereolithography, or in this case .stl, that is the PDF of 3D printing. Doesn't matter where you design it. If you export it as an STL file, you can turn it into an object. So that's pretty cool.
Is that an open format?
It is. It is. So, no laughing. This is the first 3D printer from 1983. This is his original concept. Don't laugh, this was advanced back then. 3 years later, this is the actual model, dubbed SLA-1. That was the first 3D printer that he had available for sale to the general public. And Charles Hull is remembered as the founder of 3D printers so much that in 2015 he was put into the National Inventors Hall of Fame with, I think, probably the most unique self-portrait imaginable, a 3D printed bust of himself. So that's pretty unique. Okay, so Charles Hull invented stereolithography, so let's talk about the different types of 3D printing out there. We'll start with the first one. All right, stereolithography. This is a really interesting form. Honestly, it's amazing that this was the first one. This is not what I would have thought. So, stereolithography, using lasers or projected light or ultraviolet light and a liquid vat of photosensitive polymer or resin, light is shined on the surface of the resin and it is solidified. You can see here, I could zoom in probably, you can see here as the building platform is lowered and the light is shined on the surface of the filament, or in this case the resin, it is solidified. Now, keep in mind this is sped up, so it does take a little bit longer than this is showing. So once the object has been developed, it's raised up out of the rest of the polymer, given a nice alcohol bath, and then there is your object. So this was the first type. That's a very technical way of getting it off the build plate. That's the really only unscientific part of any sort of 3D printing, is getting it off the platform. So there you go. That is stereolithography. It is still used today. If you think about it, it's actually a very good form of 3D printing. It involves more chemicals than we're willing to deal with here in the library. But if you think about the detail you can get from a beam of light, from a laser beam, you can get very detailed, very smooth prints out of this type of system. All right, next up we're going to get a little bit more mainstream. Now keep in mind this is just the largest different types of 3D printing out there. There are more than I'm going to show in this session, but these are the big ones. Okay, metal powder fabrication. This is a type of 3D printing They use a process that involves any type of metal alloy, certain types of ceramics, various other materials that can be laid down on a flat surface in some cases, and then high-powered lasers are shone down at the filament or at the powder where it is sintered with an S. I'll explain that in a minute, where it is, let's say, melted into a solid object. And then another layer of powder is laid on top of that. Lasers are shown down again to where you can get an object built up layer by layer, fused together from the metal powder. The build platform in this case would lower, and then it would raise back up, and you'd have your beautiful object. So let's take a look here. Get closer, there we go. So this is just an example of one of the machines. There are many companies that manufacture these devices, but you can see how, again, this is a model, how it would lower down, slowly melting layer upon layer. Build platform is raised back up. The excess powder is scraped away, which can be recycled, so it's not that wasteful as it looks. And there is your object. It's a really brilliant process. This type of 3D printing is already being used in aviation to create parts for jet engines, turbines, things of that nature. It's a brilliant form of manufacturing because it creates, and this is important, 100% usable parts on the fly, in an instant, particularly things that normally would be very difficult to machine in a standard manufacturing process. If you think of a part like that, trying to put it onto a lathe and trying to machine it out, very specific angles, very good detailed things like that. Now, slow down you. This is another type of laser metal deposition. In this case, the powdered metal is fed through these tubes here, and a high-powered laser is shown where the powder is being added, and it creates a weld pool to build an object layer by layer. And this one's pretty cool too. Again, this creates fully usable metal parts and components that, again, can be quickly manufactured. You see this is sped up intensely. That is 8 hours to build an object roughly this size. So pretty impressive. This type of printing is very similar to what you all might be more familiar with, which is what I've got up here today. Similar, but not exact. Okay, so let's get to it. Third and final type that I'm going to talk about is extrusion. This is the form of 3D printing that most people are familiar with. You use a layer of, or a spool or a pool of base material. In the case of our printers, we use spools of polylactic acid or PLA plastic, which is completely biodegradable, and it is fed through a heated nozzle, which in this case is called an extruder. The nozzle melts the filament, and then it deposits it on a platform, layer by layer, where it solidifies, creating an object. Anyone who's ever used a hot glue gun, you're looking at a very advanced one. It's as simple as that. Might have to, there we go. Okay, so the fun part about extrusion is it can use an incredible variety of materials. In this case, we're using plastic. It can also be used with concrete. It can be used with sugar, with chocolate. It can be used with glass. It can be used with metal alloys. Really, there's no limit beyond the imagination and the capabilities of the machine. What I've got here are a couple of time-lapse videos of how the process works, building up layer by layer. This is a good macro shot of how thin a layer of filament these things can lay down. Your hot glue gun is going to give you maybe, I don't know, 1/4 inch of layer of thickness. These can get to 0.1 millimeters of thickness. That's 100 microns. And that's just our machines. There are some that can print far smaller than that. Now those were time elapses. This is video I shot of this printer actually working and printing out this little guy, a fully articulated robot that I wanted to test out. So the real printing speeds vary. Something like this, that'd take you about 2, maybe 3 hours. It just depends on the complexity of the shape, how it's arranged on the build platform. There's all sorts of variables, but we'll get more into that later. So, moving on. How do you get access to these marvelous devices? So last semester, OSU partnered with the Department of Entrepreneurship to purchase 4 3D printers. Our philosophy right from the start was the same as the old adage that we all know. You give a man a fish, he'll eat for a day. Teach a man to fish, he'll eat his whole life. Well, here we're here to teach you to fish. We don't want to be just another fabrication lab where you can just come in, throw a flash drive at us and say, print this, and then come back 8 hours later and Iron Man suit. We want you to model your own Iron Man suit. We want you to learn the basics of 3D modeling. We want you to learn how these devices work for many reasons. Most importantly, at this time in your lives, really, if you can put on your resume, yes, I have experience with 3D modeling. Yes, I have worked personally with a 3D printer. Yes, I know how the process works. That's going to impress. That's something that's going to really help you in the future because these things are getting faster, they're getting more efficient, they're getting more reliable, and they're not going away. They're just getting cooler. So, what we've developed here in the Edmon Low Creative Studios is a type of competency assessment, let's call it. Basically, what we require you to do is using any sort of modeling software of your choice. As I mentioned, stereolithography file format will work with any type of software with these printers. So, use the modeling software of your choice. If you're already experienced at modeling, this shouldn't be a problem. If you're new to 3D modeling, that's okay. Myself, my staff, we've all been trained in the basics of 3D modeling, and the software we're encouraging new users to use is called Blender. You can download it for free. It is an open source software. You can get it from blender.org, and luckily enough, there are tons of tutorials on there as well. Speaking of tutorials, we also have access to a website some of you may have heard of called lynda.com, where you can get professional grade tutorials in all sorts of software. So that's something to look forward to. Or if you want, you can sit down with myself, one of my staff. We are more than happy to show you the basics. Basically, I keep saying basically, this is what we're going to have everyone model. This is, I guess you could call it a dog tag. It's created using basic shapes, cylinders, cubes, custom text, some sort of ring or a torus structure. This is what we ask people to model, and we'll show you how to do this if you don't know how. When people are done modeling their tag, put your boyfriend's name on it, whatever, we have them bring it in on a flash drive, schedule an appointment with me, any of my staff, and we'll sit down with you, make sure it has the components we ask for, and then we will walk you through the process of how these machines work, how to properly level the build plate and why that's so important, how to properly add the filament and why that's important, problems that can come up. If done properly, you can eliminate all sorts of issues that might arise with these. So that's why we have the assessment. It's not so much for our benefit, it's for yours. So come in and learn how to fish. So, who's going to use this? That's the question I usually get. Isn't this just for engineers? Isn't this just for aviation majors that are modeling the next plane that they're designing? Which in some cases, yes, that is true. One of my patrons was actually designing an experimental aircraft, and he printed out his models here. So yes, if you're very advanced or if you're just a beginner, this is for everyone. I would like to show you this. He was kind enough to share one of the videos of this model. This is a scale model, obviously, 1/6 the size. But this is him and his teammates doing a test run of this plane out by the airfields. So they went from concept to design to model to prototype to full functioning version in just a matter of weeks. It was a brilliant design. So going back really quick, who is this for? The better question is, who isn't it for? I mentioned the engineering, the aviation majors. What about people who are in theater and need a prop to print? That's possible. What about people who are in fashion or art? I might have 3D printed these earrings or this bracelet. There's all sorts of things. There's medical fields. I'm sure some of you have already seen articles of people printing out prosthetics. That is completely doable. There are teaching materials. I've had zoology majors coming in here and modeling molecules. There's all sorts of things that can be done. So I have difficulty trying to imagine anyone who wouldn't be able to use these. Even if you're at your house, you're staring at your wall and you're saying, you know what, that needs another coat hook. You can print out a coat hook. There's all sorts of things here. So, back it up. Whoa, it's still going. Okay. So let's take a minute and talk about the future. 3D printing has been around for about 30 years now, and it's only recently really taken off insofar as public attention. They've recently reduced severely in price. You know, they've become more accessible. It used to be something that you could really only afford if you were doing some major design work or some really consistent manufacturing. But now, a device like this is only about $2,500. Still an investment, but not completely beyond reach. If you think of what a computer cost back then and what they cost now, you know, they're only going to get better. They're only going to get faster. They're going to get more popular. I'm not saying they're going to be in every household in 20 years, although I'd love to, you know, make a prediction like that and have it come true. But point is, like any other technology in its infancy, it's going to get better. If you remember the first cell phone, I'm sure you've giggled about that with your friends compared to what we have now with our iPhones. So the potential is, right now this uses a single extruder to lay down one line of filaments at a time. Why not 2? Why not 50? Why not 100? Or how about an extruder doing one type of material and an extruder doing a different type of material? That's being done right now. It's being worked on. Right now, if you lose the back to your remote, you can print out another back and you're good to go. That's easy. In the future, you could lose your remote and print out a new one. We don't really know. The potential is there. We just have to develop the technology. And the more familiar people are with these devices, the more interesting they become. There's new possibilities being realized every day. So I do want to really quickly share with you a couple that I'm really excited about. The first being in the medical field. There was an article published recently in a Nature journal, I believe it was called Nature, of a biotech company that has developed a form of 3D printing using the extrusion method, just like this. At so fine a resolution, they were able to use a biopolymer and 3D print an ear, which was then implanted in a test subject. And because the print was so well done and so fine, the body actually formed a capillary structure within the ear itself. And the tissue wasn't rejected. That's a big problem with medical implants, is necrosis and tissue rejection. So right now we can print out prosthetics. Maybe one day we can print out new arms. I should mention also they printed out a piece of skull, which they also implanted in a test subject. The body, amazingly enough, realized where this implant was, what it was, and started depositing calcium into the print. Some really exciting things going on with bioprinting. All right, next up, I mentioned before the extrusion method can use any type of material that can be liquefied and then later solidified. Construction. So you see the size of this. What's stopping us from making one as big as a room or an office building or a hotel? Nothing, because they're already doing that. This video here was shared with me by a gentleman in Singapore, where he designed and modeled a functional hotel suite using 3D printing and 3D modeling. He then created a 3D printer on such a scale that it prints out concrete, layer by layer, creating walls, creating a building. He printed himself a hotel. Really exciting stuff. They went back later on and added the plumbing, they added the electrical, all that sort of stuff. This stuff is possible. And right now, this I'm really excited about. There's kind of a bit of an arms race going on to see who can develop the best building printer, because something like this couldn't just be useful for, you know, building houses quickly, building facilities quickly. Excuse me. This could be used in ways that we can't even imagine right now. And that's my next one that I'm really excited about. So you've heard the expression, the sky is the limit. That usually applies to something new and exciting. Well, in this case, the sky is no longer the limit. This is astronaut Barry Wilmore on the International Space Station holding up a 3D printed wrench. In the most recent Soyuz capsule launch back in 2015, they brought up a 3D printer very similar to this, using the extrusion style method. They were also kind enough to share the design with us, so I was able to print out one of my own. Working, ratchet. Any of you ever worked on any home improvement projects? What happens when you drop your wrench? Obvious. What happens when you drop your wrench when you're in an EVA environment working on a solar panel on the International Space Station? It's 100 miles away in an instant. That's a conversation I would love to hear. Excuse me, NASA? Yeah, go ahead. You're going to laugh. But anyways, so point is, this is a really exciting thing. Using the exact same type of machine that we have here, they're printing in space, not just for objects that you might need on the fly, because obviously weight limits on the shuttle prevent, so many backups of your backups of tools being carried up with you, but it's just a really exciting thing. And if you think of the fuel, the resources that it would cost, instead of having to ship up a new wrench to fix the project you're working on, and a Soyuz capsule loaded with millions of gallons of fuel, you send an email with an STL file in it. That really is a quite exciting thing. I mentioned the construction before. How about this? What's to stop us? If we get this technology going as good as it can, what's to stop us from prefabricating an environment on the moon? I know that sounds quite literally like a moonshot, but it's possible. The Mars 1 mission is already planning to include 3D printers in their first colonizing trip to Mars. So future astronauts might be able to arrive onto a distant planet where an environment has already been created for them using 3D printing. Point is, this technology is already here. It's not going anywhere. It's getting better and more exciting every day. And you've never had a better opportunity to come in and learn how this stuff works, to get some experience with it, to learn to fish as it is. So that's what we're here to do. We're here to provide access, and I look forward to seeing all of you right here. Thank you so much. Wanted to take some time quickly to answer any questions you might have. Sir?
How much does actually using the 3D printing lab here at OSU cost?
How much does it cost? You'll be happy to know that we don't charge for the filament or for the time used. All of these marvelous colors you see here, we have all of those different colors of filament available. The library does not currently charge. We're considering it. We're keeping track of how much we're using. It's possible in the future we might, but right now, we don't charge for it. So, yeah, that's exciting. I should have mentioned that. Thank you. Yes, sir?
You mentioned earlier the different programs that you can use for it.
Sure.
Can you also use like SolidWorks or something else like that?
What type of software can you use with it? You can use SolidWorks, you can use Autodesk, you can use GIS, you can use Blender, as I mentioned before, you can use Maya, you can use ZBrush. There are just about any type of modeling software has the option of exporting your object in stereolithography format. So yeah, I've yet to run across one that we can't use. You had a question?
How long does it take to print a little object like what you have up there?
This here, I should have mentioned the assessment process to print out your tag. This takes about 12 minutes and uses about 1 gram of filament. That's about 5 cents worth of plastic. I've been metering. The assessment process itself only takes about a half hour. So it's not a very big time commitment. And I should say, if you're thinking that this is just too beyond you, think again. 6 months ago, you know how much experience I had with 3D printing? 0. I knew what they were. I knew kind of how they worked. But I taught myself to model. My background, for the record, is in sociology and wildlife ecology. It's not technology. Anybody can do this, and everyone should. Good question. Yes, sir?
What kind of materials can we use in this?
In the library, we're sticking to PLA plastic. We're steering away from ABS because it has to be a bit hotter, and we're in a very flammable building. So we're restricting it just to PLA for now.
Can we use any kind of material in this?
With these specifically, or with any other device?
Any other device?
Any other device, the restrictions are only to what the hardware limits are. This printer is capable of printing in ABS, PLA, flexible filament. It has a lot of capabilities, but we're sticking with the one for now. Any other questions? Yes, sir?
Can we get approval for another material type and bring a spool of that for use in these?
I'd have to get back to you about that. I'd have to talk to some bosses.
We do have one question from Twitter.
Yeah.
It's, what is the coolest thing that's been printed in Creative Studios so far?
Ooh. What is the coolest thing that's been printed so far? I'd have to say it's a tie. Well, this, as I mentioned, is the aircraft that one of our patrons printed at a 1/6 scale model. This is a 1/4 scale model with him printing it in various components to measure their effectiveness, their wind resistance. And this next to it is a model of the engine that they strapped to the real one to get a test for sizing to adjust the I guess the capacity of it. That one, I think, ties all of this with the Millennium Falcon. I have to say, the detail that you can get with these printers is pretty amazing. So, yeah. Any other questions? Feel free afterwards to come up and ask me anything. I know I'll tell you everything I know. All right. Well, thank you all for coming. We've got some more stuff from Amelia here.
All right, those were some great questions, guys. If you're interested in learning more, we encourage you to visit with some of our knowledgeable staff here at the Edmon Low Creative Studios, or you can check out one of our logins for lynda.com, which offers thousands of online training videos on a number of topics, which actually includes getting started with Blender and also 3D modeling. Thank you to our friends at OkState TV for hosting today's live stream, and we want to say goodbye to everyone who is online with us today. And this is actually our last Tech Tuesday for the semester. We'll be returning next September, where we will have plenty more great prizes. And speaking of prizes, let's go ahead and draw for today's prize. We're drawing for a 3D printing pen. But today, we're going to start with the...
We're going to start with the small ones?
Yeah.
Okay.
We're going to go ahead and start with this lovely water bottle. So, drum roll. And the winner is Aaron Davis.
Aaron? Okay, we have two 16 gig flash drives.
All right, our next winner is Ushab.
Imbin?
Oh. Okay, and our second flash drive goes to Julio Garcia Dominguez. All right, and the 3D printing pen goes to Rudya Raj Pendrella.
Yep.
And we have our Okay. So congratulations to everybody. Make sure you talk to Paige to get details about finalizing your award. There's lots more chances to win at each Tech Tuesday at 2. And another way you can win big this semester is actually at the Library Creativity Award, where we will be awarding a total of $600 in prizes. You can visit our website or ask any of the staff if you'd like to learn more. If you have suggestions for future Tech Tuesdays at 2 topics, please send them to us via Twitter with the hashtag LiveTechTues. Thanks, everyone.
We are looking to the future as to where we can make things readily available that our students need, that our faculty are going to use. We want to inspire the creativity. We want to inspire research. This is a great place to start, a great place to play and enjoy and learn. We just put in new 3D printers. We're very proud of them and very proud of the use they're getting here in Creative Studios. We have a Mac room, and we have 3 high-powered Mac machines, and our second studio has 3 really souped-up PC Windows machines. Within reason, we have all the different software virtually the same on each one, so that the students will have a choice whether they like Mac or they like PC. Our third creative studio is a presentation studio. It includes enough chairs for a very small audience, a podium, a green screen, as well as a projector. This room can be used for Skype interviews. It can be reconfigured any way the student would like to do it, whether they're doing an interview, a group talk, or some kind of special meeting and Skyping with someone at a different area. We are thrilled to have this addition to the OSU library, and we hope your ideas can come to life here in the Edmon Low Creative Studios.
Creativity. Well, I guess it's in all of us. That's really hard to define.
It doesn't really look like one thing or another.
It's taking something and making it extraordinary.
It's putting your own stamp of quirky on it.
It's reading a chapter in a history book and being inspired to write a poem.
It's taking a camera out for an adventure.
It's finding an innovative way to treat a patient.
Everyone can be creative.
So don't be afraid to think outside the box.
There are over 8 million things in the library to be inspired by. The Library Creativity Award. Make it